Then we're going to be quiet for a second so I can finish this. We are going to realize that I'm multiplying this whole thing by cosine x. So I'm going to shortcut this a little bit by already distributing it to both things. So I'm going to have cosine x times 1, and I'll have cosine x times this negative cosine x, which is going to give me cosine x minus cosine squared x. Then on the bottom, I have sine squared x times 1 minus cosine x. Now, the thing that's going to trip you up here is you need to realize that this negative affects both of our numerators. So this negative is going to give me a negative cosine x, but it's going to give me a positive cosine squared when I push these things together. If you don't realize it, this problem's not solvable at this stage, if you don't realize that. So I'm going to distribute this negative to both things, which is then going to give me, on top, we'll have sine squared x. We're going to have minus cosine x. We'll have a plus cosine squared x all over sine squared x times 1 minus cosine x. Now, it looks a little chaotic right now, but what we need to pick out of here is sine squared x and this positive cosine squared x. What does sine squared plus cosine squared equal? It equals 1. So I'm going to replace both of those with the number 1. So both of those become 1. Doesn't matter if I put it before or after that cosine x. I'm going to put it before because it makes more sense, because that's going to give me 1 minus cosine x over sine squared 1 minus cosine x. We're going to see these cross out. Don't make it a 0 on top. A 1 goes in its place. So I now have 1 over sine squared x. So if I come, let's just finish this off right here. This will equal 1 over sine squared x, which I would change to cosecant squared x. So the correct answer is cosecant squared x. Now, was this the easiest way? No. It was not the easiest way, but it works. It is you recognizing that I have two fractions, push them together. Let's go in our way, way back machine and choose a different method. Way, way back machine, and I look back here. Now, when I look back here, I'm going to notice something else sticks out to me. I have two fractions, and I also have a 1 minus cosine x. 1 minus cosine x screams to me that I need to multiply by the conjugate. That's that 1 plus cosine x. So I'm going to start there before I try to. And in fact, if you know what happens when I multiply by a conjugate, you actually know what this is going to change into, and you're going to know what this is going to look like afterwards. So I'm going to take 1 plus cosine x, and I'm going to multiply the top and bottom by that. So my top becomes just 1 plus cosine x. All over my bottom is a difference of squares. That's 1 minus cosine times 1 plus cosine. That's a minus b times a plus b, which turns into a squared minus b squared, which in this case would be 1 squared minus cosine squared x. And that's minus cosine x over sine squared x. What does 1 minus cosine squared equal? That just equals sine squared. So this whole thing just equals sine squared. So that forced it to have a common denominator. That is you practicing these enough to realize if I multiply 1 minus cosine x or 1 plus cosine x by its conjugate, you get sine squared out. If I have 1 minus sine x and I multiply by 1 plus sine x, it turns into cosine squared. So that's just you realizing this times its conjugate equals sine squared, and you're like, oh, that should work out. I now have a common denominator of sine squared. Now when I do 1 plus cosine minus cosine, my cosines actually cancel out. So this would be 1 plus cosine x minus cosine x all over sine squared x. Cosines cancel out. 1 over sine squared is cosecant squared. Now for my money, that's easier, But did both get the correct answer? Yes. That's why I keep stressing, when you are on the test, do something. Don't just stare at it and see how many steps you can get to in your head and go, nope, I don't think it's going to work. Because I can't give you points for what you're thinking about. Try something. If it doesn't work, don't erase anything. What I would do is I'd grab a scratch sheet of paper from me and try it a different way. Because as soon as you start erasing, all of a sudden you run out of time and you have no points. And I guarantee on this test, it happens every year, I'll circle something that was erased and I said you were on the right path here, but I can't give you points. So if you just had it, you would have got points, but you changed stuff and you kept erasing and now you don't have those points. All right? Questions? Hey guys, I handed out 2 review packets for you. One is the total chapter review. It says Unit 7 review. The other one is just identity practice. You know your strengths and weaknesses. You know there's a test coming up after break. I think it's like that week after we come back. So we have 2 lessons, a review day, and then a test. We have 4 class days. So it's still time. But that review, Unit 7 review, there's only 2 concepts we haven't covered. Those are those 2 extra things. I'm going to borrow this for just a second. So that's that double angle and half angle. So if there's anything about double angle or half angle, you can't do it. Everything else you can do on there. So if you're someone that needs to do well on this test to even pass or get the grade you want, it might behoove you to take this week and actually start that review. That way you have a full week to ask me questions on stuff you don't understand. Now, there's also a verifying one. I handed you one with a cover page that says just verifying practice. If you need practice verifying, great packet to go to. A lot more problems than verifying. Like I said, it just takes practice. There's only so many different types. In fact, I put the 4 major types right on that front page, and it walks you through what you should do when you kind of see this kind of example. So verifying, it seems like you just try random things, but they really fall into certain categories that if you realize these categories, they become a lot easier. All right, questions on those reviews? Okay, then let's go over questions from the homework. Yeah, go ahead, Drew. I can, maybe. I don't know. Is it a hard one? I can't do hard ones, so hopefully it's not too bad. So, Drew, if I was looking at this, I would stop right here. I said get rid of weird stuff. Cosine of x plus y is that weird stuff that you have to do first. No matter how complex the right side is, I have to deal with that first because going backwards is a lot harder. You guys realize that in the homework. When I had ones where like I had the 30 plus 45, you plugged in the equation and you came out with your answer. And then all of a sudden later in that homework, I gave you the stretched out thing and you had to condense it. And a lot of us struggled on that. For some reason, it's harder to take something big and condense it like that. So I'm going to expand that. So I'll go to my identity sheet and realize that cosine of an angle plus an angle. These are both in places of our alpha and our beta. Well, if you look at your little sheet that I provided on your test for you, those particular identities, cosine of an angle plus an angle is cosine cosine minus sine sine. So I'm going to rewrite this as cosine of our first angle, which is x, times cosine of my second angle, which is y, minus sine x, sine y, all over cosine x, cosine y. Put an equal sign there, so I'm just working on the left-hand side. Now, here's a step that we've done before, but it looks a little more confusing in this capacity. What I'm looking at here is, in our numerator, we are adding in or subtracting. We are subtracting in this case. But I'm looking for, are we adding or subtracting? If you were adding or subtracting in the numerator, you could split it apart into 2 fractions. And the reason why I know to split it apart is because this right side does not have just 1 fraction. There's 2 of them. There's 1 over 1, and we have these tangents over 1. So I'm going to split this apart into the 2 fractions I can, which basically splits this. It becomes the denominator of both of those. So splitting this apart turns into cosine x cosine y over cosine x cosine y minus sine x sine y over cosine x cosine y. And in fact, that's the last step we really have to do. Because what happens if you have the same thing on the top and bottom?
1.
It equals 1. They cancel out and become 1. What's sine over cosine? Tangent. So this is tangent x. And we have sine y over cosine y, which turns into tangent y, and you are done. You okay?
I just stabbed myself.
Well, don't stab yourself. All right. Is that good? This is a good test question because it tests whether you know to do this first, and it's a little buried in there. And I also like to check to make sure you understand that you can split apart fractions as well as put them together. So I would log that way under a good test question. Yeah. Yeah. I'm going to cheat a little bit. I'm going to take a picture of what I had on the answer key, and then we'll go over what stuff we want to specifically work on. So number 3, we were given a bunch of information, and I am cheating. All right. Do you want us to work through any particular one to see how I got the particular values?
Can you do the cosine value?
The cosine alpha? Yeah, we can work through that. So the first thing I would do, so say I'm on a test, I see sine alpha minus beta. Write what it means. Even on proofs. So even if I give you a proof, what do? If you see a double angle, you write what it means. So that's what we're looking out for, those angle addition or subtractions right now, so we can write those out. So I write those out. They tell me sine alpha equals this, so I fill in sine alpha. They give me cosine beta equals negative 8 over 17. So let's locate what we know. We know sine alpha. We know cosine beta. So we need to find cosine alpha and sine beta. So the question was, can I find cosine alpha? Now, Lewis, did you do it the way where you do sine squared plus cosine squared equals 1? Or do you understand the shortcut? I can do it either way.
Well, I did it with the sine squared plus cosine squared.
Okay.
But I couldn't figure out what the shortcut.
Let's do that. That's fine. So the shortcut only just... Let's just do it the long way, and then we'll look at the other side and see how I kind of shortcutted the process. I do not encourage you just forcing yourself to use the shortcut. Use the long way if it makes more sense. Okay, so we know if I'm looking for cosine alpha, cosine squared alpha plus sine squared alpha equals 1. I'm going to need a little help on this one, so if someone has a calculator handy, you can help me out. So we know that, hey, sine alpha equals negative 24 over 25. Notice how I'm careful not to circle that square because I don't want to replace that squared. That squared stays there. All right, so now I'm going to have cosine squared alpha plus a negative 24 over 25 squared equals 1. What happens when I square a negative? It becomes positive. Can someone help me out here? What happens when I square 24? 576 over 625. That makes more sense. Which means I'm going to rewrite the 1 as 625 over 625, so I can see that subtraction happen. And I'll have cosine squared alpha. Now we're going to go ahead and we're going to subtract this from both sides to get it over here, which is going to give me 49 over 625. So I have cosine squared alpha equals 49 over 625. Good so far, Lewis?
Yeah.
All that stuff makes sense? Okay, now we have to take the square root of both sides. So I'm going to take the square root of both sides, knowing that I need to pick whether it's positive or negative at this stage. So I go back up to alpha. I find alpha. Alpha is in quadrant 3. Quadrant 3 is all students take. Tangent is positive. That means cosine is negative. So our answer is going to be cosine alpha equals a negative square root of 49 is 7. Square root of 625, we're going to go back to that 25.
Yeah,
So all the shortcut is, so what I want to notice, we subtracted a number from both sides, right? And then we took the square root of it. Look what happens in the shortcut. I subtracted the number that's being squared, and I'm taking the square root of it. The shortcut puts everything on the right-hand side, where this takes you moving stuff every single time. So picture the shortcut on this one. I just need to plug it in, square it, and take 1 minus it. Do this method. If this doesn't make, there's no reason to do a shortcut if it doesn't make sense. It's only for, hey, I got it down. Like, I get what's happening, 100%. I know where a shortcut comes from. This will not be provided for you on the test. Like, it's not an identity that we memorize, really. But some people just, like, get it. They're just like, I'm going to do 1 minus that squared. I'm going to take the square root of it. So I can, in my head, do most of this. This is just our shortcut. But I highly encourage most of us to go through the whole rigmarole of it. Lewis, is that enough for you to try sine B then? Yeah. Okay. All right, other questions? Okay. Today is kind of a day where I'm just going to, they're slightly challenging questions. They're slightly challenging questions, and then we'll get easier after we go. So we're going to do this first one together. We'll start the next, maybe we won't even start the next one. But we're going to do the first one together. What makes this really, really complicated is actually this multiplication right here. I've already said, as soon as we see an angle addition or an angle subtraction, I have to do that first. I don't care if the right side looked super complicated. That trumps things looking complicated. Angle addition or subtraction trumps it. So if I was to do this problem, I would look at my identity sheet. Okay, sine alpha plus beta. I can rewrite that as sine cosine plus cosine sine, which would look something like this. We're going to have sine alpha cosine beta plus cosine alpha sine beta. So that's that red part. That's that sine alpha plus beta. So this left-hand side is going to get pretty complicated really quick. So if I look at the other one, the only difference is there's a subtraction. It's still sine, so it becomes sine cosine minus cosine sine. So we're going to have, for this pink one, I'm going to have sine alpha cosine beta minus cosine alpha sine beta. Now, we don't need to have those memorized, but I think at this stage some of us start to recognize that stuff, at least those patterns. Now, you have two options here. I have a binomial times a binomial, so I can draw my arrows and multiply them, and I can multiply them. That's a long way. What do we recognize about both of those? It's a difference of squares. It is a plus b times a minus b, so it turns into a squared minus b squared. Realizing your a squared is going to be sine alpha cosine beta squared, so both of them are going to have squares on them. So we're going to rewrite this as sine squared alpha cosine squared beta minus cosine squared alpha sine squared beta. That is our difference of squares. Yikes. That doesn't look like the right-hand side yet. Now we're going to have to do something that showed up in one of your homeworks. What's missing on the right-hand side? That's on the left-hand side. I'm missing cosine squared betas, and I'm missing cosine squared alphas. What does 1 minus cosine squared equal? What does 1 minus sine squared alpha equal? Cosine squared alpha. Now, normally we go 1 minus cosine squared equals sine squared alpha, but we're allowed to go the opposite direction. So once again, what I'm picturing in my head comes from that sine squared alpha plus cosine squared alpha equals 1. If I move the sine to their side, If I move the sign to the other side, I have cosine squared alpha equals 1 minus sine squared alpha. Well, that means if I see 1 minus sine squared, I replace it with cosine squared. However, if I ever have a cosine squared and I want to change it to sine squared, I just replace it with 1 minus sine squared. It's a shortcut to just quickly replace all cosines with sines. So what this is going to now look like is I'm going to have that sine squared alpha. I'm going to look at that cosine squared beta, and I'm going to turn that into 1 minus sine squared beta. I don't want cosines, so I just replace it. As long as it's squared, I can replace it with 1 minus sine squared. Now we're going to do the same thing for the other cosine. That should be minus. We're going to do the same thing for the other thing. We're going to take that cosine squared alpha, and we're going to replace that with 1 minus, I should probably do it in green so it matches. 1 minus sine squared beta times sine squared
Wouldn't it be sine squared alpha? Yeah.
beta. Oh, yep. Sorry, I was looking at the betas. Too many alphas, too many betas. Alpha is correct. Be careful with distributing now, because we do have to simplify this. One distributing is really easy. We have that sine squared. So I'm going to take that sine squared and I'm going to distribute it to both things. That's going to give me sine squared alpha minus sine to the 4, sine squared alpha, sine squared beta. Because they're not the same angles, they don't turn to the 4th, you can just put it in front. It's just basically x times y, you can't combine those. Now, why I say worry about the second one, you can do this in one step. I'm going to do it in 2 steps. I'm going to realize when I distribute the sign to both of these, I haven't talked about that negative that's in front of it. So we're going to leave that negative, and I'm actually going to put parentheses around this. So we're going to have sine squared beta minus, well, that's sine squared alpha times sine squared beta. Whew. This seems to be getting bigger and bigger. Now I need to distribute that negative sign. That negative sign has to go to everything. So I have a negative sine squared. I'm going to have a plus sine squared sine squared. Don't we have a negative sine squared alpha sine squared beta? And a positive sine squared alpha sine squared beta? So if I give you 1 and take it away, you now have 0 of them. So those are going to cancel out. So you're going to be left with what?
Sine squared alpha, sine squared beta.
Yeah, so we're going to be left with that sine squared alpha minus sine squared beta. And that's hopefully what the other side looks like. It does. They are good. I'd only put like 5 of these on the test. So it'll be pretty easy. I'm not going to put any of these on the test. In fact, this one is strictly optional if you want the challenge of simplifying stuff. There's some cool things that happen in this one that don't happen in this one. So we'll make this one optional. It might not be the first one you should do. Let's get our homework done first and then try the optional one. Yes? Can you hold on 1 second while I go through the homework really quick? All right, let's look at the homework together. Actually, let's do one problem together. This one always stumps people, and I don't want you to spend 20 minutes on this one when it's a really easy problem. Cosine 2x. Now, if you look at your identity sheet, have we talked about double angles or half angles? No. So we can't use double angles or half angles. I have to use something I already have to split this apart. Now, all we have are angle addition and subtraction. So in order for this one to work, I would need to have cosine of something plus something. So I know what my alpha is, and I know what my beta is. Is there any way to turn a multiplication into an addition? X plus x. So you give me 2 times x. I say I don't know how to deal with that. I'm going to make it x plus x, where my alpha and beta are the exact same measure. That's fine. I just need to plug x's into that equation, and hopefully it comes out to that. All right, this rest is your homework. I will note on the very back side, on the very back one is extra practice, 12, 13, 14, and 15. So those are going to be extra practice. Should you do them? Probably. They're nice, but I'm not going to check that as homework. So your homework is really just 3, 4, 5, 6, and then I think I have 7, 8, 9, 10, and 11. 11 is a good review question, but realistically, the back page is going to be extra. Rest of the time is yours to work. Work diligently, ask questions.